So now let's go ahead and look at insulators. And before we talk about insulators, we're going to talk about another sequence of DNA that is called an enhancer. And these are DNA sequences that can speed up or enhance the rate of transcription for any promoter sequence that it can access. So that means that it doesn't matter how far away it is, it doesn't matter which strand it's on. If it can get to that promoter, it's going to increase the rate of transcription. And obviously, you can think about why we wouldn't want transcription to be increased all the time. We might have enough of the protein or enzyme that it makes, and we don't want increased transcription. So we have another DNA sequence called an insulator that can stop the effect of enhancers, but only if it's located between the enhancer and the promoter. So if we don't want our transcription to be enhanced all the time, we have insulator sequences that'll go between the enhancer and the promoter and stop the enhancer from reaching the promoter. And the way that it does this, it puts everything in little neighborhoods. And an enhancer is only allowed to interact with the promoters within its neighborhood. And these are specifically called topographically associated domains. Enhancer can only be in its neighborhood. So if you have a neighborhood right here and right here, the enhancer that's over here can't talk to the promoter that's over here because it's in a different neighborhood, and the insulators are going to be blocking that interaction. So let's draw really quickly what that would look like. So if I have a DNA sequence, let's say I have a promoter right here and an enhancer right here. If that's all that there is, anytime that transcription is happening, the enhancer is going to be going over there and saying speed up, speed up, speed up, speed up, speed up, and nothing is going to be able to block it. But now let's say we add an insulator right between our promoter and our enhancer. Now our enhancer tries to get over there, but the insulator says, stop. This isn't your neighborhood. You can't come over here. This means that the enhancer can no longer affect anything to the left. It can only affect things to the right, since there's no enhancer on that side. So it can do anything on that side. But anytime it tries to move to the left, that insulator is going to say, stop, you can't go any further. This isn't your spot. This isn't your neighborhood. Well, let's try moving this insulator somewhere else. What if we moved it after the promoter? Could our enhancer have an effect? Well, yes. If we were to move our enhancer to show where it can reach this promoter. The place it's going to be stopped is after the promoter, because if it tried to go any further, your insulator would say, stop, you can't keep going, that's not part of your neighborhood. But because the insulator isn't between the enhancer and the promoter, it can't have an effect on that one. So, in order for it to have an effect, it needs to be located between your enhancer and your promoter. All right, in the next video, we'll be going through the different types of RNA interference.
I hope you found this video really helpful. The concepts and information presented in these videos will be true no matter what genetics class you are taking. However, the concepts presented in this video are referencing material currently covered in Baylor University's coursework. Remember, if you are currently enrolled as a Baylor student, we offer free tutoring services. Our tutoring center is located on the first floor of the Sid Richardson building. You will find all the details you need to know about these services on our website, www.baylor.edu/tutoring. You may schedule a free 30-minute one-on-one tutoring session online through Navigate, or just drop in during our open business hours. For more information about our current services, please visit our website. Thank you.